yet. Hidden deep inside one of America's most secure aerospace facilities, a machine worth nearly $2 billion. Behind these giant doors, thousands of engineers, technicians, and advanced robotic systems work together to build one of the world's most sophisticated aircraft. Long before the first piece of metal is cut, every section of the aircraft is designed, tested, and perfected using advanced digital engineering.
Thousands of virtual simulations verify strength, aerodynamics, structural integrity, and mission performance before production can begin.
Once every design passes inspection, the factory begins receiving the specialized materials needed to build the aircraft. Every shipment is inspected with extraordinary precision before it is approved for manufacturing. Computer-controlled machining centers begin transforming raw materials into aircraft-grade structural components. Every finished component is measured with microscopic accuracy before moving to the next production stage. Meanwhile, advanced composite materials are transformed into enormous lightweight structures that help define the bomber's unique shape.
With the first major structural sections complete, the stealth bomber finally begins to take shape.
The bomber's center fuselage forms the backbone of the entire aircraft, supporting everything from fuel systems to mission electronics. Thousands of aerospace-grade fasteners permanently join the aircraft's major structural sections together. Dozens of robotic fastening units move simultaneously. Every structural connection is verified using advanced laser inspection systems before production continues. Now the bomber's enormous flying wing structure begins coming together with extraordinary precision. Even the smallest alignment error could affect performance, making every adjustment critically important. Robotic arms install lightweight internal ribs, equipment mounting frames, and structural support sections throughout the open fuselage. Miles of electrical wiring are carefully routed through dedicated channels before the aircraft is enclosed. Hydraulic systems, fuel lines, and environmental control equipment are installed one module at a time.
Every installed component is digitally documented, creating a complete manufacturing history for the aircraft.
With the airframe complete, the stealth bomber is finally ready to receive its advanced engines, cockpit, and mission systems.
With the airframe complete, the bomber enters one of the most sophisticated phases of manufacturing: systems integration.
The aircraft's digital brain is installed through a network of powerful avionics computers and mission control systems. Next comes the cockpit, where pilots will command one of the most advanced military aircraft ever built.
Thousands of electrical connections link every onboard computer, sensor, and flight control system together.
While the cockpit is completed, powerful engines undergo their own series of inspections before installation. Computer-controlled lifting systems position each engine with extraordinary accuracy. Laser-guided positioning systems make microscopic adjustments. Fuel systems, hydraulic controls, cooling lines, and engine electronics are connected before operational testing begins. Every moving control surface is activated and tested before the aircraft leaves the assembly line. Advanced diagnostic systems verify every onboard function, ensuring the aircraft performs exactly as designed. With its engines, cockpit, and mission systems successfully integrated, the bomber is ready for one of the most demanding stages of production. Every panel, seam, and structural joint is examined with advanced optical measurement systems before final approval. Automated finishing systems apply precision protective coatings with perfectly controlled consistency across the aircraft's exterior. Sensitive measurement equipment continuously verifies coating thickness and overall surface uniformity. Each completed section undergoes multiple rounds of inspection to ensure it meets exact engineering standards. The aircraft is then moved into a controlled environmental chamber, where temperature and humidity remain carefully regulated. After environmental conditioning, another complete inspection confirms the aircraft is ready for final integration.
With the exterior approved, The aircraft is prepared for comprehensive ground testing.
Every completed aircraft receives a fully documented production record, ensuring complete traceability throughout its service life. After months of precision manufacturing, the stealth bomber is finally ready to begin its extensive program of ground evaluations.
External power is green across the board, moving to the auxiliary systems check.
All right, I'm showing nominal values on the heat exchangers.
Power flows through thousands of electrical systems as computers begin a complete automated diagnostic sequence. Flight control computers command every moving surface through carefully programmed operational tests. Hydraulic pressure, fuel delivery, environmental controls, and backup systems are verified under simulated operating conditions. Now comes one of the most anticipated moments: the first engine start.
The engines gradually come to life as engineers monitor hundreds of performance measurements throughout the aircraft.
With engine performance confirmed, engineers prepare the aircraft for independent ground movement.
The bomber slowly taxis across the flight test facility while engineers evaluate steering, braking, and overall handling.
Every successful ground test brings the aircraft one step closer to its historic first flight. With every system performing flawlessly, the stealth bomber is finally cleared to begin its first flight evaluation.
After months of engineering, manufacturing, and testing, the moment has finally arrived. The stealth bomber lines up for its first evaluation flight.
Engine power steadily increases as the aircraft begins accelerating down the runway with remarkable precision.
With sufficient speed achieved, the aircraft lifts gracefully into the sky, marking the beginning of its first flight. Engineers and test crews carefully observe every stage of the aircraft's climb using advanced telemetry and tracking systems.
Throughout the flight, onboard systems continuously collect valuable engineering data for detailed analysis. After completing its planned evaluation profile, the bomber begins its return to the airfield. The landing approach is carefully stabilized as pilots prepare for a smooth touchdown.
The aircraft touches down smoothly, completing another important milestone in its development. Back inside the hangar, engineers begin a comprehensive post-flight inspection, comparing test data with expected performance.
Jolly time. From raw materials to first flight, every stage reflects decades of aerospace innovation, precision engineering,